For the first problem, this one pretty easy. We just have to derivative the s equation because we have velocity is the first derivative of the s and acceleration is the second derivative of s, mean the first derivative of the velocity. Now we have to solve for the acceleration equal 0 because so we're gonna have two values of t. We know that the time had to be positive, so this one gonna be rejected. Next, we gonna have to substitute the t value into s and b. So we're gonna have the solution. The next one, so I just wrote out the information I have over here. We have v equal v0 minus ks. This is the equation come from a textbook. Now we just so it asks for the initial acceleration of the projectile. So because yeah, so we had s is 1/3 and v0 is 900, so we just substitute in here. We're gonna have the 0 equals 900 minus k times 1/3. We're gonna find the k over here. And then for the initial acceleration of the projectile, we're gonna have a equal b, the first derivative of the velocity. So we're gonna have from here to here, and substitute the v0 in there. We're gonna have the answer. For the b, it asks for the time required for it to like 3.9 inches into the block. We're gonna have t equal, yeah, pretty simple. You have to solve this one. Just put the dt over here and like divide this one to the side. We're gonna have this one and then just do the integral for both of them. We're gonna have t. For the third one, we're gonna have so we had a acceleration over here. Acceleration again is the first derivative of the velocity, and one more time we just put the dt over here to this side and divide this one to this side. We're gonna have this one and find the t. Okay, because the problem asked for the depth of the lake, so we will have to find the v first. The v first over here with respect to t, and then integral this one to find the s, and then substitute 3 seconds into the s that we found. We're gonna have the depth of the lake. And then just substitute 3 into the velocity equation. We're gonna have the velocity of the ball when it reaches the bottom of the lake. For the next one, doing the same thing, we're gonna have v equal this one. V mean ds over dt, the first derivative of s, and then doing the same thing, just divide this one over here, the dt over there. We can find t. Okay, and we already know that over here t equal 1. Just substitute in here, and we're gonna have the distance after 1 hour. Right here, substituting. And for the b, it asks for the acceleration. We're doing the same thing, just find the v. We already had the v, and derivative the v to find acceleration. At t equals 0. And the last question is the time required for the joggers to run 6 miles. So this is the S equation. I just substitute 6 over here to find the t. So we're gonna have t equal this one. Chờ em xíu. For this one, I just did the same thing. This one we have the equation. Equation right here. Acceleration is this one. This derivative of both of them. We want to find this one. So we have b0 over here. We just multiply it over here, we not have this one. Okay, so this one I gonna just call this part S, and this part y. Now 1, 2, 3, so we're gonna have s plus 3y is constant. We derivative both of them. We're gonna have vs plus 3vy equals 0, and one more time we're gonna add acceleration of s plus 3ay equals 0. So we had y decrease 4 inches. It means s increase 4 times 3 means 12 inches. Because the velocity was given in feet per second, so we're gonna change this one to feet over here. We're gonna have, because we have vy is 2 feet per second, we're gonna have from this equation we have velocity of s is minus 6 feet per second. And so we have this one is the formula we know. Ay is called this one. To substitute them in, we now have ay is equals 6 feet per second square, and from that we're gonna have as from this equation. Same thing. Chờ xíu rồi nó học bài. So with this one, we just use the simple equation. A equal v square minus v square over 2s. Okay, and let's do the b first. And the a time required, we're gonna use this one. So I found the time required to decrease the velocity from the speed from 600 to this one, and then the time that it decrease the height from this to this, and then the time that decrease the speed from this one to this one, and just add them up together. We're gonna have this one. Number 18 is just derivative thing, so I'm not gonna measure this one. God, nobody gonna watch it anyway. So it all about equation formula. I don't even know what to say. It's just formula. This one. So I just find the s and y of b, the s and y of c, and then find the velocity needed to make the ball fall at b, the speed, the initial speed needed to make the ball fall at c, and then the initial velocity gonna be between those values. Okay, 11 and 12, they use pretty the same formula. This one, so nothing to say. This one is just the same as problem number 6. This one is a little bit harder. I think the most important thing is because at first I read and speed up at the rate of 10 feet per second square. I thought it was just this one. I totally forgot we also had the an over here. So the most important thing is we have to remember the 10 feet is just 80 the acceleration tension to the loop, and we also have to find the an over here is the acceleration toward the center.